Hello YouTube and welcome back. Yes, I'm still honing. No, I'm not the same engine. All that being said, let's get to the video. This is the full video of the 5 videos that I broke up out of this full video. So sit down, relax. It's going to be a long video. There's a lot of great info in this video, and let's get to it and we'll talk about it when I come back, or when we come back. Hello YouTube and welcome back. Today I have a special guest, Lake Speed Jr. I know I'm as excited as y'all are back there watching. So I want to let
I'm
that.
excited to be here. What are you talking about?
There we go. So I want to chill down a little bit, but this is great. This is awesome. Thanks for visiting.
Well, it's great to be here in Texas, and I can't help but think if we're here in Texas that there's a correlation between chili and engine performance.
Okay.
Right. So
yeah. Exactly.
So
I see where you're going with this.
If everybody who knows me probably knows where I'm going with this, right? Like you said, but so if you're making chili, you got to make sure that you've got the right tomatoes. You got to have the right ground beef and the seasoning, and of course there's a thing here in Texas, either beans or no beans. But we won't dwell on that right now.
Yeah, that'll be another video.
So the whole key is you got to have all the right ingredients for the chili to turn out right. You're not going to win the chili contest if you're just kind of
if you don't get the chili powder right. Done.
Yeah,
you don't get any part of the ingredients.
All the ingredients. It's putting them in the correct order and how long you cook it and the temperature. It's everything has to be right for you to get the winning chili. Mm-hmm. That makes sense, all right? Well, it's the same thing for ring seal, because what ring seal is really the pumping efficiency of your engine. Your flow, that's all your camshaft and cylinder head, all the cool people, fun stuff,
yeah,
right?
you can spend all the time getting the air in.
Right.
And getting it out.
But if you don't have piston rings in there, guess what? It's not going to pump very well.
Yes.
They're just going to make a lot of motion and not do a lot of work. So ring seal is about having the right cylinder finish, the right cylinder bore geometry, the right oil retention, the right ring contact. Everything has to work correctly to create good ring seal. I always call it soup, but since we're here in Texas, we're calling it chili today. Right, that's the idea. So that's really the key thing that I think when people are looking at their engines, we were talking earlier today that before you just drop off your block at the machine shop, you might want to think a little bit about what type of ring you're using, because this ductile moly ring will optimally need a different surface finish than this steel ring does.
And that's great advice, because we don't want to brag on the machine shop. They got a lot of work to do. They're out there trying to get this stuff out as fast as they can, and they want to do good quality work. So they may not sit there and go, hey, by the way, what ring are you using so we can give you the right finish? If you now, because of the video, you can actually learn and be proactive, and now when you go to the shop, you can ask about the ring finish that you want.
Well, because we know what happens when you assume, right?
Yep. Yes.
There's an old saying about that. So you don't want to assume that they're just going to give the right finish, because they may assume that you're using a moly ring.
An older, and they're going to give you a finish that can work for everybody. So it may not be the best chili, but it's chili.
Right.
So we're going to give you a ring finish that's going to seal with the cast ring. Mm-hmm. It's going to seal with the moly ring. But if you start you into a chrome ring, so they're going to give you a little bit of rubber. So yes.
You got to adjust it. And that's the way to get the best performance and best durability, because like we most know, one size fits all tools typically don't fit anything well. Will it work? Yes. It will get you off the side of the road from being stranded 9 times out of 10.
Back in the day, it was a cast ring and a medium to rough finish for quick break-in, and that was basically it. You had 3 different rings: we had a cast ring, a moly ring, and a chrome ring.
Right, and that was how it was in the old days. Like you said, you could have a pretty basic finish and cover 2 of the 3 pretty well. The moly ring and the cast ring were pretty forgiving because they were soft; they would break in real easy. Now the chrome ring, boy, it was hard. So you had to make it rough. And then there was all these different myths about break-in. Transmission fluid and Bonami. All those things came from the chrome ring days. Because that chrome was a more durable, wear-resistant surface.
Good for blower, good for temperature, cylinder heat.
It was great for all that.
But not good.
It was hard to break in, which is why the whole idea of the Moly type rings came around. Because you go back to the history, we went from cast rings to chrome rings. Because that's what made that cast ring.
Industrial usually had a chrome ring.
Right, because the base material of a chrome ring was still cast iron. Mm-hmm. It was just a chrome face coating. So all you did was change the face coating. You didn't change the material of the ring.
And people don't realize that a Moly ring is still a cast ring.
Yeah.
It's still, if you look at it sideways, and I've done this in my video, they're both a dark gray cast.
Oh yeah.
It's the face of it. We're talking about a Moly
embedded ring. It's not the whole ring made out of Moly. So what contacts the cylinder bore has unique characteristics in terms of what the friction coefficient is. In the Moly rings, because it's a sprayed on process, creates porosity. So it holds oil like a sponge. And really the best way to think is, we wouldn't put a cylinder head on this block without putting a gasket on it. And not expect it to leak at least, right? So the oil is the gasket between the ring and the cylinder wall.
And a way that you'll see a bunch of old school techs and stuff, when you're doing a compression test and you call somebody and go, hey, my cylinder's low, what's the first thing they tell you is squirt some oil in the cylinder and do another compression test. Because without oil, you have no ring seal. So you really need, I know you want to think about it, we don't want oil in the cylinder. With no oil in the cylinder, we're going to have high friction, high wear, and no ring seal.
Right. You want oil in the cylinder, you just don't want it up in the combustion chamber.
Yes. So you need it at the right place. You need that lubrication, but you need the seal. It actually is what makes the perfect seal.
Oh, exactly. So that's what that surface finish is about. Exactly. So that's the whole beauty of the Moly ring, was that it had that porosity that could hold some oil, which meant the surface finish of the cylinder could be a little bit smoother. It could be a little more varied because it wasn't relying on the surface finish of the cylinder alone to hold the correct volume of oil. When you go to a steel ring, well, this material is much better than a cast material. Mm-hmm. So it can last longer. It can handle more heat for turbos.
All modern engine, even and the first when we started getting into blowers, we started getting into turbos. We started getting into the chrome ring and a better ring because of the heat. Mm-hmm. The thing that now, just a regular mom and pop car, they've increased the cylinder temperature out because of efficiency. So now we're running engines at 210, 220 degrees, and they're not overheating.
Right.
They're taking them up to the higher temperature for better efficiency. The hotter heat in the cylinder makes less friction. So now we're having the regular soft cast ring ain't going to hold up in an environment that we have higher temperatures, but yet it may not even be a blower. So really nowadays engines run hotter. Now you put a blower, a turbo, nitrous for sure, and you're going to increase the temperature way up even more.
You think about it. Old 289 Ford made like, I think, 280 something horsepower, something like that maybe, right? And barely 1 horsepower per cubic inch. Well, a Ford EcoBoost is half the displacement, makes the exact same power. So it's double the horsepower per cubic inch.
Way more efficient.
Way more efficient. And of course they've gone from the old school cast 564, 3/16 rings. That little EcoBoost has a 1.2 millimeter top ring.
That's like a sheet of paper.
Steel. That's a steel top ring with a 1 millimeter second ring with a 2 millimeter oil ring. So that ring package is literally less than half the thickness of the original ring package, but it makes twice the horsepower, and that engine will live probably at least 200,000 miles.
Yes.
The cylinders will, right? Because it's just better metallurgy, better coating technology, better cylinder bore finish. And that's really the thing, is the OEMs, because of fuel economy, have really mastered the art of cylinder seal technology, from bore materials, surface finish, ring materials, ring coatings. They've got it down to a real science. And what we're trying to let people know is, hey, you can utilize this newer technology of the steel ring. You just need to adapt the honing and the running in process to it, which goes back to your original thing. You have to know what questions to ask, what to tell your machinist when you're getting this stuff done, to make sure you get the correct ingredients so you can make the right chili.
Yeah, and the hone. Let's talk about the hone itself.
Yes.
It serves two purposes. Okay, so the hone actually holds oil in there.
Yeah, the crosshatch does. Correct. Yep.
But the thing that we always cared about, we didn't really care about the second part, and I shouldn't say, but talking about, honestly, we grew up in the machine shop world, and you want to get stuff out, and it has no comeback, no warranties. The thing you want to think about is ring seal.
Yep. You want to seal up sooner rather than later.
Yes. Yeah, and so we were concerned about ring seal, but the finish is what helps the ring seal. It was what helps the ring seal. Back in the day, we had to leave a cylinder finish a little bit rougher. It was abrasive. That's what actually made it the ring to the cylinder. And it holds oil, so since it's holding oil in there, it can last longer. So there was a fine art of what's rough enough to seal fast and not too rough that actually, your ring's not going to last long.
Let's call it locks of the three bears, right?
Yeah.
Not too hot, not too cold. You want it just right.
Just right.
So you were trying to find that just right, and you were doing it based on the ring material and the coating you had at the time. And so as things have changed and evolved, you have to evolve that. What's right.
And it's time for us to evolve. That's the cylinder finishes have gotten to more. It's for sure just one finish ain't gonna fit all. But before we had three finishes that could pretty much. That's not it anymore. So
that's just one aspect, right? That's one small thing that's evolved in engine technology is the evolution of the ring materials and coatings and the related surface finishes that go along with that. That's just one thing in these engines that's evolved that helps make them more durable, more powerful. I mean, even just from the piston ring perspective, back to the size. Going from the 564th, 3/16 rings down to where a 1 millimeter, 1 millimeter, 2 millimeter ring package is what I would recommend to anybody for a street car anymore.
That's like I said,
anybody.
That's just like a thick piece of cardboard. It's not very, very, very thick. And you would think it's that thin. How can it still hold? It's amazing what they can do with rings these days. I mean, just so thin, but yet they'll last for 200,000 miles. I mean,
well, you think about this. If you had a piece of cast iron and you dropped it, it's probably going to break. If you have the same piece of stainless steel and you drop it, it's not going to break. The material technology and the coating technology has come so far in the last few decades. We did that video recently about my dad's old engine. It was a 2002 NASCAR engine, and sure enough, 043 ductile moly top ring and 1.5 millimeter second ring, 3 millimeter oil ring. That was thin, state-of-the-art stuff at the time, back then. Well, today, those same guys are running a 0.5 millimeter top ring. So when I say a 1 millimeter ring is like a street car engine, I'm not even exaggerating. That's twice the thickness of what a NASCAR ring is. So it's
going to be interesting to see the gains of that. I know you're freshening it up.
Yeah.
And are you going to do one that is nothing but a ring change?
So we're going to do everything at once. So this is we only have like a limited window. So we're going to change the cam. We're going to change the rings and the pistons. We're going to change a whole bunch of stuff. But the thing is, it's all going to be inside. We're not changing the oil pump. We're not changing the oil pan. We're not changing the heads. We're not changing the manifold. Everything on the outside of the engine will look the exact same because it's going to bolt right back into that car.
So you're still flowing the exact same amount of air. It's still the same animal.
The same animal.
It's just an efficient one.
We're just going to try to change all the internals, like you said, to make them more efficient. We're going to, talk to the guys at Comp Cams about, okay, what cam grinds we put in here? What can we do for valve springs? I look at those old valve springs back then. Man, they were monsters.
We could go on springs just alone. I love the Beehive spring. It was a different world back then.
Yeah.
And it is not that world anymore.
Like, you don't need that much spring.
No, in fact,
anymore.
you want to get
Right. I don't know how much horsepower is going to be in those springs, but it's going to be a bunch.
All we cared about a long time ago was high RPM valve float. And in our mind, the valve float tears up parts, and that's all we cared. So put as much spring pressure as we could.
Overkill.
Yeah.
Everything was overkill on spring pressure.
Yeah, not anymore.
Which is one reason why the engine was down so far on power. Is because
if you ever turn the motor over
for 20 years.
When you put
those big monsters on there, it killed all the valve seats.
Turn the motor over, and as you start putting the springs on and the rockers on, And if you got the 300 pounds of spring pressure times 16, I mean, just think about it. There's more loss in horsepower just turning the valve train.
Oh, I mean, just to give you some round numbers. So those valve springs, installed pressure was about 300 pounds on the seat, right? Which some of that's kind of crazy. But they're racing roller cams, 2 valve engines in NASCAR today. Ooh, man, there's some guys who are a little bit less than 100.
I was about to say because the lifters, we could go on in a series of videos just on new technologies, but the lifter issue, the new comp stuff, one of the last winches that I did, I think it was 100, no more than 110 pounds on the seat. I mean, yeah. I mean.
So we can literally cut the seat pressure in half.
That was
and still be okay.
Yeah, that was a Z28 Camaro had 100 pounds on the seat when it came from the factory.
Right.
I mean, that was unheard of kind of. We would, yes. Now,
and that's all about changing the push rods, changing the rocker ratios.
All it has to do with friction,
and the dynamics of all those things. So that's what's kind of neat, is to see the evolution of race technology and what's available for people today. Because, I mean, literally what was state of the art in NASCAR 20 years ago, anybody can buy today. And there's actually even better stuff that you can buy today.
Like I said, you go to the dealer and buy an Eco. I really do love that engine. But just the regular stock technology that you just buy today in an average engine is an amazing. The engines today are race engines right out of the box. I mean, they're just
a lot of that technology is right. If you look at the new V8 engine that Chevy's coming out with for the Corvette, the twin overhead cam piece, man, that's straight up race motor right there. I think it's got a 0.8 millimeter top ring in it.
That's a Formula One engine.
It's really cool stuff to see what the OEMs are embracing, and they're bringing race technology to the market, and it's not the old school trade-off. To me that's the best part of all this, is that in the old days it was, well, you want to make a lot of horsepower, it's like a top fuel car. Well, it won't last very long.
Yeah.
Right. You had to trade off. Right. If I want to make a lot of power, well, my stuff's going to blow up.
I'm putting a new set of pistons every run. So
right. Well, you don't have to do that anymore. That's not a trade-off that has to be made. You can get parts that are lighter, stronger, and more durable. You don't have to trade power for longevity. You can actually get both in a lot of cases if you know what questions to ask on the front side and do your homework and figure out the right combination, because I'm sure you see it all the time. You know, people go buy the best parts, but they're not the right parts for the combination.
It's not out of part. They saw a YouTube video or something, and I bought I bought what Billy's doing, and they bring in these parts, and okay, I want to do this.
Right.
Yes. And it is kind of a little bit on the they'll spend so much on parts, and then I want to skip on the machine work.
Right.
I don't want a torque plate on it. Well,
now you want to do that, by the way.
I don't want to balance the motor.
You want to do both of those things, by the way.
I tell everybody, if you're not going to do anything at all, just balance it.
Oh yeah.
And he goes, well, I know, but I want more horsepower. That's okay. You will.
Yeah,
just
balance it.
It doesn't sound. I mean, it sounds neat when back in the day balancing blueprinting, but yes, but
there's a reason for doing that, by the way.
Yes, they'll skimp on some of the things that you spend $1,000 on a set of pistons without a problem, but you're going to skimp on. Do you really got to put a torque plate on it? Do you really have to? Yeah.
That brings up a really good topic of conversation, by the way.
Okay.
Balance and blueprinting, because if you go way back in the day, you didn't have a catalog of race parts you could buy.
Yep.
So if you think about it, maybe a house analogy, where today's fancy parts you can just buy off the shelf and bolt them on, are the modular kitchen where you can buy all the cabinets and everything, and they just come in, they just fix it all up, right? That makes for a beautiful kitchen. But in the old days, they had to hand make all that stuff. But before they ever did any of that, they made sure the foundation was right. Because if you don't have the right foundation under your kitchen, what's going to happen? Well, the foundation is going to break and the kitchen is going to fall on the earth.
Yeah, it don't matter how nice of a kitchen you built, it ain't going to last long.
Right. The foundation in the old days was the balance in the blueprinting. They did that to everything to make sure they had the correct finishes, the correct clearances, everything was straight and properly aligned. They made sure the foundation was sound before they started making custom parts themselves.
An engine just balanced and blueprinting sounds different.
Yeah.
And I have people go, well, your engines just sound just different. And I go back to the whole thing that Smokey said. We're building 8 individual engines connected by a common crankshaft.
Yep.
So if you have the same CCs in the combustion chambers, the same deck height, that's just blueprinting, just setting the deck height.
Yep.
And a lot of guys have a machine to deck the motor, but all they do is deck it because all they're concerned is about a gasket sealing.
Yes.
When a little bit extra, you could have measured the motor and square decked it.
Yep.
And all that means is all 4 corners are the same. You know, nowadays, like I said, back in the day, we had TRW pistons or Speed Pro.
Yep.
That's if you were buying aftermarket pistons. And that's basically it.
Right.
And then all of a sudden, you got, Aries, Charles and Albert. And then you wanted to spend $1,000 back then, and you got a custom piston. But for the most part, that wasn't a thing. So there wasn't many things that we could do. We'll put a forged piston in it.
Right.
But that was an awesome thing. We put a forged piston.
Big upgrade. Yeah.
Yeah, but take a regular motor and balance and blueprint in it, and just makes a difference. Kind of going full circle, all the late model cars come to the extreme balanced and blueprinted from the factory.
Oh yeah.
Yeah, it's you don't get the same, I guess, bang for the buck. I bet you if I took an EcoBoost in here and balanced and blueprinted it, it'd be just waste of money, basically. It might be an occasional little bit of a gain.
UBG checking things.
Yes, I'll be checking. Yeah, but take an earlier model, the 70, 72, 75, 78, 80s, especially 80s. And like Chevrolet used a certain bob weight, and if the piston was within 4-8 grams, whatever it's a big difference. It's okay.
Yeah,
it fits that bob weight, and because all they cared about is a bad vibration, but not a smooth running engine.
Everything today is about more efficiency, better noise in the cars. They want that to be quiet, and so to achieve that, all the tolerances have gotten tighter. Surface finishes have gotten better, which
we run 0.8 all. I mean, y'all may not do it, but
and that's not scary, by the way. I know it sounds scary, but it really isn't.
I try to get the stuff that I do, and I'm converting an older vintage engine into a modern world. I balance and blueprinted. I try to do everything. What I plan on is some motors you're not going to do it. The bigger the main journal, whatever. But I'll try to go to 1030, and everybody wants to go. Oh, I want the 2050. I said that's back in the day.
Yeah,
it's back in the day. You can't do that with anything with variable cam timing anyway.
Right, exactly. That's a good point. The modern engines with all of the variable valve timing, be it from the cam or rocker ratios, however they do it, it's critical not to use a higher viscosity oil than what's recommended by the OEM, because the oil isn't just a lubricant in those engines, it's a hydraulic fluid, and you don't want to change the hydraulic function of the engine.
And now they're using it as hydraulic fluid. Very good.
Yes.
So a variable cam timing, the way that it works, there's springs on a big cam gear, and there's oil pressure with a solenoid valve that closes the oil pressure off. So at stagnant, just sitting there, the springs hold it open, hold it all the way shut.
Yep.
And all that means is it holds the cam timing. It's what the cam was ground at.
Yep.
So whatever it was ground at, that's fine. But as the vehicle takes off, we can actually change the cam timing.
Yep.
And make more torque for takeoff. But once it gets going, it doesn't need torque anymore.
No.
So we can change the cam timing, and that's what it does. The computer says, hey, we're moving faster now. I don't need torque. We're not taking off.
Let's make more power.
It opens the solenoid. That lets oil pressure. It's hydraulic. So now we're running hydraulic items. The solenoid opens. The cam now, the oil pressure is higher than the spring pressure. So it moves the gear inside. So now we advance the cam. Okay, that's how it does that. It's all an old-fashioned hydraulics, just regular hydraulics and springs. So it's oil pressure against spring pressure. So all that's designed. Okay, the computer, all that tune is all done. As you start slowing down and you get to a light, the computer says, oh, I need torque now, and I need to change my tune from highway tune, which got me better gas mileage and more power up in. So it closes off the 2 solenoids, and the springs now, because there's no oil pressure, pushes the cam back into its natural state, and it reversed the cam. So old school, when a motor was worn out, we upped the viscosity. Let's go ahead and put 20 weights, put 30 weight. Anything with the variable cam timing, which is just about everything nowadays, that oil viscosity is so crucial to the tune of that motor. If it's too thick, it'll do a check engine light. What it does is the computer's going through and it's sensing everything really fast.
Right. Other thing too is with the modern engines, with the thinner ring packages that have lower tension, viscosity is a fancy word for resistance of flow. If I have a really high viscosity oil up on my cylinders, my oil ring tension may not be enough to actually scrape it back down. Now I'm leaving excess residual oil in the combustion chamber, and oil typically has a lower octane value than your fuel, so you can cause detonation by leaving too much oil in the cylinder. So there's a lot of reasons why you should use the correct viscosity oil. So don't try to outthink the OEM.
Everybody thinks that it's the carbon from the oil that after it got burnt that made the detonation.
The oil vapor itself will actually make it happen.
Yes, the least of the molecules that ignite with the least BTUs, least heat, are gonna set off first. What I like to say, I said, you're a kindergarten teacher and you got 40 kids in your class, and you're turning the lights down and you want everybody to just settle down, and all it takes is one to get up and disturb the class, one hyperactive, and all of a sudden everybody's bouncing off. So that's what happens with the hydrocarbons in the cylinder. Is you have a mixture of a bunch of different chemicals and molecules, and all it takes is, and you start to compress it, heat goes up, a byproduct of compression, and all of a sudden one little, I shouldn't use the word bastard out there, beep, and one guy gets off. And now all of a sudden it set off everybody.
Yep.
So oil in the cylinder, because it's a lower octane, and octane, I tell everybody, that's just money. That's just a Band-Aid because you can fix stuff without throwing octane at it. Octane is just, a lot of people use octane as a Band-Aid as opposed to the proper tune. But anyway, good. It's
no, but you're right, because a great example of that is the modern direct injection engines. In fact, all of the oil specifications here in the U.S. Have changed in the last few years. We went from what was several years ago API SN, which is the little symbol on the back of the donut there on the back of the bottle. That was the rating. We went from SN to SN plus, and that added in some protection from detonation for the direct injection engines, where we were changing the chemistry of the oil so that if there was some oil left in the combustion chamber, it would be less likely to cause a detonation problem. Now you have API SP, which is the current spec, and it's from scratch was designed for direct injection engines to mitigate that risk of having that hyperactive child that sends everything into chaos. So those are the changes, right? And that's the key thing that we're trying to do here, is educate everybody so they understand that, engine technology, from all the hardware parts, all the metallurgy parts, all the coatings within the engines has evolved and evolved and evolved. And you got to make sure that whether it's the ring seal, or it's the correct viscosity oil for your variable valve timing, or it's the correct chemistry of the oil, the right type of fuel for your direct injection engine, you got to make sure that you're following the right recipe to create the right kind of chili. That way you don't have a chili recipe and you meant to make New England clam chowder, because you're going to be really disappointed if you made the wrong stuff.
And don't get us wrong, this is actually should be exciting, especially for the younger people that are getting into this. Even for the older ones that are, we have to evolve with technology. And this is exciting. I don't know.
Oh, it's great.
We get excited about it, but everybody should be getting excited about it.
Because there's that old myth out there. Well, a motor's a motor. They're all the same. You can just do what so-and-so's always told you to do, and everything will be fine. Well, okay, if
squeeze bang sucks, that's
right. And there's an element of truth to that. Okay, we're not trying to dismiss that. But the reality is, are you trying to work for the lowest common denominator and just barely get by, or are you trying to actually push the edge of performance? Do you really want to get the best? To me, as growing up as a racer, son, and a racer myself, I don't want to settle for second place. I want to do the best I can. And
my goal isn't to go out there and get third.
No, yeah, exactly, yeah. I don't want to be the also-ran. So what we're trying to do is give you the perspective of understanding that, engines from one era are going to have certain parts, certain metallurgy, certain finishes, and then an engine from another era is going to be different. but you don't have to just accept that, well, that engine was from the 60s. You can't do anything modern to it. Well, yes, you can. You just know what you can do to it and adopt the right technology.
This is a Hemi. Our early model Hemi. This happens to be a brand new. It's going to be a 572, but it's old technology.
Yep.
But like Lane says, Shop Mom always says, I get all excited on some of the different projects and stuff. Especially when we're going to take this older technology. It's a brand new. It's never been run, but we're going to give it to modern technologies.
Right. Flat type of cam, gone. Roller cam, in.
Yes.
Big giant thick rings, gone. Gas-ported thin rings, in.
Yes. There's the diamond pistols right there. We got, so we got
cast iron heads gone. Aluminum heads. Aluminum
head. Yes.
We talked to it, said you're done.
It said we've faded enough that it has to start all over again.
Right.
So yes, old technology out. Old engine, old vintage engines, put the new technology in, and you'd be surprised. It's just you get a way better engine. And it makes so much more power without the old way would do when it came in.
You mean that you don't have to have an LS engine to have modern technology?
Yes.
Did I say that out loud?
I like to tell everybody on the flathead Fords. I use my LS technology when I build a flathead Ford. Yeah. So you can't unlearn something. So you can't learn something and then okay great and then go back to your old ways on a flathead Ford. No, that technology that I learned on that, you can't unlearn knowledge. And don't be scared of knowledge. Knowledge might not be what you want to hear. But embrace it because it might not be what you want to hear, but you might be a way to change for the better.
Oh, exactly.
Knowledge is never bad.
I think most people want more horsepower. They like things that run more reliably. They like things that run cooler.
Yes.
So by applying the new technology even to older engines, all that's possible.
Without doing the old-fashioned way to doing it.
Right.
The old-fashioned way to do it, it'd come in and we'd up the compression. We'd pop a pop-up piston, a big-ass cam, and that's it. With the price of fuel today, so you can actually make an engine more efficient, make more horsepower, and end up getting better fuel economy.
Oh, so think about these Marine guys who have to run 89 unleaded non-ethanol fuel because that's what they can get the marina.
Yeah,
they're making 1,400 horsepower on these things all the time.
A lot of times, what I can say is, how much with the price, how fun is it when your car's in the garage because you can't drive it?
No, cars are fun when you drive them.
So we don't do and even though everything now more efficient, we can have more compression, but that's not the way to do it anymore. Not run 12.5 to 1 compression on a street car.
Right.
You can get plenty of power with 9.0. I mean, golly, you can be very efficient. If you have aluminum cylinder heads and you know how to tune, you can get 10.5 on pump gas.
Oh yeah.
Yeah, I mean But anyway, that being said, there's more efficiency, more bang for the buck, and you don't want to lose that through the rings out into your oil pan.
No, because I'll tell you this. My history was being the oil guy at Joe Gibbs and formulating oil, testing oils for race teams. Fuel and blow-by is the absolute enemy of your oil, and your piston ring is your oil's greatest friend. Yep. So you want to keep the fuel and all that stuff up here, not down in the crankcase. And
even with the best rings, if money's no object, the best people, the best rings, everything, I tell everybody, because I get people go, no, you're going to have compression gases going past the rings.
Oh, yeah.
There's just no way to have 100% of not one little bit of compression gases. That's just part of the nature of it.
Right.
But that's why you want to be in control of it.
Right.
I remember when the 5.0s came out. The 5.0 Mustang, the Fox body Mustang.
Yep.
They dominated the racing, especially when they started putting turbos on them.
Yep.
But everybody, shouldn't say everybody, a lot of people blamed the cylinder ring package with the 5.0s, and they're trying to do all kinds of different things. And they're going back to the older school, thicker ring, and I'm talking about the turbo guys that are doing this. You know what the problem was? Well, you know what the problem was with this? Because of the less ring tension.
Yep.
Crankcase ventilation.
Yeah.
Is crankcase ventilation. People don't realize they take all that stuff off. And they put 2 breathers on. If it's a drag car, they put the evacuation system to the exhaust. And the first thing, when we were growing up, we bought a car, and the first thing we did, we put tires and wheels on it, and we put a chrome air cleaner.
Yes, sir.
And a set of Mickey Thompson valve covers.
Yep.
So I get it. We took all the ugly stuff off. The first thing we did was take off an EGR valve until I grew up and I knew the importance of an EGR valve.
Yeah.
But then, the first thing we did is take all the emission stuff off, and put a good set of, Mickey Thompson valve covers with dual breathers.
Yep.
Okay. All that worked back in the day because we had bigger. The 5.0 Mustang did not like that.
No.
If you don't have positive crankcase ventilation, if you're not pulling on the crankcase, the rings won't seal.
Yep. Exactly.
They need vacuum for the rings to seal. Once the rings seal, the compression, it holds them.
Yep.
But crankcase ventilation is really a strong part of perfect ring seal.
100%. I mean, that's a big part of it. In fact, when we were working on my dad's new engine project, because of that old pump, I mean, it was only pulling about 7 inches of crankcase vacuum. Well, it should probably pull about 14, but the modern cup stuff, those guys are pulling, over 20 inches of vacuum. So we're not going to go all the way down to a 0.5 millimeter ring because we don't have the oil pump to get there. That. So, right? But we're going to go to a 0.7 millimeter ring because it can do that. But that's the whole, I mean, you're spot on. Having crankcase vacuum enables things you can do on top of it to make the whole engine more efficient, because that's really the story. Engines are systems. It's not a collection of parts. They are complex systems. So you need to think about your engine from a systems perspective, and think about it from the perspective of what you're trying to accomplish.
You can buy the best ring. You can have the cylinder finish the best. Mm-hmm. And these newer rings, thinner packages, like I said, if you don't pull a good vacuum on them, they're not going to seal. Right. And then you're going to go blame the machine shop, or you're going to go blame, and everything nowadays is a low tension ring. So that's another thing too. Back in the day, we had high tension rings.
Right. And you don't want high tension rings, so this wears your cylinder bore out faster.
Yep.
So to make your stuff live longer, you need a lower tension ring, but you need to have the complete package. And so it's just all about having the right mental approach to what you're trying to do. Understand the fuel, understand the application, begin there. It will dictate everything else.
Yes, and like you said, the recipe, you don't want crappy soup, so right. or crappy chili. You take out one of these of everything. Depending on what part you take out, you may not see much difference, but depending on what part you take out, you may totally see like it's not working and you're blaming somebody else. But it's the whole package.
Yep.
It is the whole package. Especially with, like I said, rings are the most advanced. Cams, yes, but cylinder finishes, cylinder rings, cylinder ring finishes, the coatings on them. I mean, embrace it. Don't run away from it.
Right. It's the number one source of friction in your engine.
Yep. The number one source of all.
Of all the friction sources, and there's lots of them. More of it comes from this than anything else.
And does that include a flat type of cam?
Yes, sir.
Wow.
Yeah.
I learned something today.
Yeah.
I would have agreed with that just not even knowing, but with the roller cam, I thought we would have. That still is the number one.
Even a direct bucket action, right? Because that's essentially a flat tappet.
Uh-huh.
Yeah. Still number one.
So that ought to be the biggest eye opener right there.
Oh yeah. Yeah, it's like when the Formula One guys start building brand new engines, they call us. Right? It's like, how do we cut friction out of this thing? Because when you're turning a lot of RPM, the more RPM you turn, the greater contribution the friction is.
And the friction is just taken away from all that hard work and money that you designed to build horsepower. Then now subtract the stuff that you're giving away freely.
Friction is the tax man, right? All the cool stuff comes from the camshaft, the manifold, the cylinder heads, all that cool stuff. Taxman shows up, that's friction, and it's trying to steal all your fun.
So you had 100 horsepower, and the taxman comes in, and now you got 80 horsepower if you're lucky. Right. But yeah, so that's a good way to put it there. Yeah. I like that. So because that's what you don't realize is that, golly, you'll spend $1,000 on something that gets you 5 horsepower, and yet on something that's less than that, a set of rings, and you won't spend the money on that.
Well, I'll tell you one other one. Oil level. Guys who have stroker engines, more times than not, have this factory pan or the stock pan, and they never change their oil level to compensate for the deeper stroke.
And the windage is
man, I've seen 25 horsepower.
And the 25
from
horsepower
1 quart of oil
doesn't have nothing to do with what you're doing to your bearings with all the air.
Oh, we don't even talk about that.
Yeah, we're just talking just the windage.
Yeah, just the windage alone.
Just the windage.
Yeah.
And on any other,
make the oil run hotter, makes the water run hotter. It's just
with the air in the system. I mean, the oil system, it just turns everything up.
Yeah.
What I tell everybody about that, I go, next time you're at the pool, put your hand flat and hit it when you're laying in the pool. Hit it. Now put your hand angled and hit it, and just see how water also like Bruce Lee. You know, water can be soft and water can be hard.
Yeah, exactly. Yeah. Like the Bruce Lee angel. There you go.
Well, I like that's one of my Smokey and Bruce Lee. You know, and Tesla. Okay.
There you go. Cool. Well, man, thanks for letting me come by and hang out for a little bit.
Oh, that's great. It's amazing. I think I'm still going to do it, and you know, may edit, might not edit out. I'm going to put myself on the sword, and I want to see something, and I think y'all might want to see it too. If you beep and then it ends, we're over. Then I think. Would you mind?
Yeah, we can check the box. Sure.
We're going to do something. Now, you want to tell everybody what you're doing?
Yeah. So this is a Mitutoyo profilometer. It's called an SJ210, which is a surface roughness measuring tool, so it can see down to about a millionth of an inch. So it's pretty fine, pretty cool stuff. So what we're going to do is we're going to put it in the bore, and I'm going to turn it on. Oh, it's not liking that setup. What we can do is we can just put it in here just like this, right? And then I'm going to hit start. And when it's doing it, there's a diamond tip stylus in there, and it's going to drag it along the cylinder, and it's going to measure the surface roughness of that cylinder. And then it's going to give us a printout of what that surface roughness is. So this one's coming back as an RA of 17. What we can do is we can kind of page over here, and that kind of gives you that little picture.
That look of what, there you go.
So you can see the peaks and the valleys, and this is a pretty good looking profile. They call a plateau type finish. And the way you can see it is this curve right here. So this area up here is the peaks, which is going to rub off during break-in. And then this is their core roughness, and that little turn there is the valleys. So that's going to be able to give us, so we get back over here to the part where you can really see the trace again. Those are the valleys that are going to hold the oil for both ring seal and for lubrication. And then those peaks are going to wear off over time. So that's actually not a really bad looking surface. Pretty good, bud. That surface roughness would work with both the moly ring and a steel ring. And then that RZ is their total peak to valley height, and that gives us, that's a good number that kind of says, hey, you know what, this surface, that'll get the job done.
All right. So I'll leave this in.
Yeah.
And what we're talking about, when you bore in a boring bar, no matter what boring bar you have, it's actually a violent thing is happening. So when you bore, you have a carbide cutter bit, and whatever bit you want to do, it's ripping the metal.
Yes.
So as it's coming around, and every time it goes around one time, it drops, and it just sits there. And if you look at it, microscope, look at it with any kind of magnifying glasses, it's hard. It's just, it may look smoother. It's really just, ripping the finish. No matter how nice it looks, you will never run the ring with that bore finish.
No, it's a cutting tool.
It's a cut, and
so it's cutting and leaving tears and all that stuff like you would normally expect from cutting something.
Yes.
Honing is completely different. It's an abrasive, so it's smoothing. It's more of almost like lapping. And so what we were seeing is, okay, those deeper valleys were probably from residual from the boring bar, but now it's come in and it's smoothed everything out so that you have a smoother running surface, but you still have some of those deeper valleys to retain the oil.
So you figure they're just high spikes. So as you come in with the hone, you're starting to take off the high spot. You're still going to have the valleys, but you're starting to work the high spots off.
For this being an RV, this is going to see pump gas. Mm-hmm. That's a perfectly fine finish.
Okay.
But if this is going to say same block, same engine.
In an alcohol car.
An alcohol car, take that mid-step out and go all the way to size with your rough abrasive, and then just kiss it with the final abrasive.
Really?
Yep, that will basically leave that same smooth on top, but it'll give you that deeper valley underneath.
To hold, because it's alcohol is washing all the oil off the
cylinder. Yes, exactly.
Yes, that's why you do. Yep. In alcohol, you want to change the oil out, if not every race, at least every week, every night of racing. But because you're dumping so much of alcohol in the cylinder, it gets in the oil.
Right, your air-fuel ratio is essentially double.
Yeah.
So you have to run twice the amount of alcohol, essentially, than you do gasoline to maintain the proper stoichiometric ratio for the combustion to happen correctly. So when you do that, that extra volume of fuel going through the cylinder is going to try to wash the oil off the wall, which is washing away your seal and your lubrication. So by adding more valley to the finish, you're retaining more oil to fight against it.
Awesome. I love that. That is all. Like I said, that's why you end up with so much alcohol in your oil after a night of racing.
And what happens a lot of times is people will hone an engine for alcohol engine just like you did, and then they struggle with ring seal. They struggle with fuel dilution because they're not getting as good a seal as they could because they don't have enough valley to hold enough oil.
Another reason why, do you think the guy at the machine shop is going to ask you, hey, are you an E85? Pretty much not say pretty much. I'm real bad of saying never, always, pretty much. A lot of the guys nowadays have gone to E85. And a lot of the young guys, I guess, are boosted applications.
Right.
Everybody's running E85. Now, once again, I shouldn't use the word everybody.
Well,
but a lot of people
who are running boost are running E85.
Yes, especially in the street cars. They're making crazy. They're running nines. I mean, it's a different world than we were growing up. You know, if you ran a 10-second quarter mile, you were bad to the bone.
Right.
Now, if you're on a 9, you're a punk. You're like, yeah. So it's a different world now. But the finish is like I said,
it's more critical. The higher you go in horsepower, the more critical all the details are.
So you almost gotta be proactive, and when you walk into the shop, you gotta ask for the finish.
You gotta tell them what you're up to.
Yeah, because if you don't tell them you're running 85,
I'm running a steel ring. I'm running boost. I'm running 85. They need to know these kind of things so they can hone the block correctly for your application.
Like I said, don't blame us. Well, I got a problem. I was telling you earlier about.
Don't blame the rings. Don't blame the oil. Don't blame the cylinder guy. Don't blame all that stuff. It's a combination, and you got to make sure that you're telling the cook that you want chili, not clam chowder.
Yeah. I think we're done. It's awesome. Yeah. All right, so I think I'm keeping this there. And thanks for stopping by. Always good visiting with you. We can go on and on and on, and this camera will shut off again.
Exactly. It's already cut us off once. That we're done with y'all. Y'all talk too much.
So we'll see y'all later. Thank you. I got to get to work. All right. Video ended. Welcome back. Hope you've enjoyed this. This is a video I shot with Lake Speed Jr. We went all over the place, talked about a lot of stuff. Really, it should be enlightening and exciting to get back into this business. If you're not doing this, get into this business. If you're just building an engine, now you've learned that you need to be a little more proactive. You need to talk to your machinist, ask them what kind of finish they're going to use. They don't know what kind of ring you're going to use. So, like Lake likes to say, horsepower and the tax man. We're making a lot of horsepower, but we're leaving a lot on the table. So I hope this was educational, informative, if nothing else, entertaining. All right. Tell your buds, tell your friends, hit the like and subscribe if I do put some there. If not, even if I don't, hit the notification button. It's the little bell with the line going through it. Get rid of the line. You'll be notified when we're coming on. Hope you've enjoyed it. As for me, I do got to get back to work and finish these cylinders.